This is my brand new Onefinity Elite Journeyman, and if you're not familiar with Onefinity terminology, the Elite basically means their top product, the Journeyman is their middle in size. Now regular viewers may be questioning why I didn't do an assembly video on this like I usually do. Well, the reality is it was very easy to put together. We're literally talking 4 parts, the 2 Y rails, the X rail, and then you bolt the Z assembly onto it. It was ridiculously simple for a machine of this size. And at the end of the day, Stone is much more efficient at putting these together than I am, and his videos do a brilliant job of walking you through it. So it would have just been a rehash of basically content that is already out there. But back to the purpose of this video, making a spoil board. Now my machine is set up on the Onefinity frame, which does make life easier because you get the T-track in place in order to hold everything down. And as you can see, I've already cut some pieces of MDF down for the initial bed. But ultimately, I need a spoil board on top of this because a spoil board is one of the first things that you should do pretty much on any CNC machine. Now, when it comes to designing a spoil board, it is a personal choice and there are lots of options and variations out there. Some people like to put thousands of holes in for different bolts, bench dogs, those type of things. Other people like to put lots of grid lines on with circles and different shapes for alignment purposes. And then you get the people that just plonk a piece of MDF on top and leave it at that. I'm kind of going somewhere in between with a mixture of those. I want to utilize the T-track slot, so it's going to be a slotted spoil board, but I also want a couple of holes in between those just for extra clamping positions. Because if you're doing smaller items, some of these gaps can be a little bit too wide. I'm also then going to put a few grid lines on just to help for alignment, but ultimately I'm trying to keep it as simple as possible because I think lots of holes would personally be overkill for me. Now the first thing I need to do is cut the material down to size to fit this. Now fortunately, the width of the bed itself should pretty much be able to cover side to side with a surfacing bit. So in terms of the spacing of the boards itself, it will pretty much mirror what we already have in place here. However, as you can see on the far right hand side, the spindle doesn't go all the way to the back. So we've got to cut those boards a little bit shorter. Now the reason we do this is ultimately your spoil board should not really be any bigger than the area that you can machine. Because when we come to surface it later, which is taking the top layer off to make sure everything is flat, if your work area or your spoil board is bigger than your work area, you're going to end up creating yourself a little pocket. And that means nothing will ever then sit perfectly flat if it is closer to those edges. So rule number 1, spoil board should always be about the same size as your work area. Maybe a little bit more if you're using a wider surfacing bit. So first thing for me to do is to cut the depth of the boards down to fit within the work area of this machine. So let's take a closer look at what I'm trying to achieve here because people will have questions. Now the first thing people may notice is I could have just put a thicker piece of MDF down on the frame originally instead of a second layer. There are 2 reasons I haven't done this which are kind of related. The first is each of these pieces is held in place by about 10 different bolts. So ultimately every time I needed to change the bed for a new one, that would be 50 bolts that needed to be taken out and put back in order to change them over. The second reason is your spoil board should be disposable. Your bed it should not be. So it's often better to have a spoil board that sits on top of your bed, and that way you can just replace the spoil board when you need instead of changing over the entire bed. So that is why I've got a double layer going on here. Now these have been cut down to the same length. You can already see they're cut to the same width of the existing panels that are in place. The next thing I need to do now is get these stuck down in position directly on top. Now when it comes to holding your spoil board down, again there are multiple options. Some people may prefer to use screws, nails or bolts, either from the top or from underneath. Me, I'm just going to be using normal double-sided tape to hold it down. There are a couple of reasons for this. First, when the spoil board needs to be replaced, it's much easier just to fetch this off and prise the old boards up and put new ones down on top of it. The second reason, which is quite important, is it means there's no metal within the spoil board. So I don't have to worry about running into a screw or a bolt should anything go wrong. So for my preference, this is just better and safer and easier all round to stick the spoil board down with double-sided tape. So all the double-sided tape is in place. I've gone for 3 strips on each plank just to make sure there is enough support across the whole board from left to right and obviously front to back as well. I've trimmed up the edges just to clean them up where possible, and now I'm just going to take off the other side of the tape, flip these over and stick them perfectly on top of the existing bed pieces, which I'll do now. So everything has been stuck down nice and secure. We've got a lot of spaghetti left over. There is obviously a deep groove in between the T-tracks because of the thickness of the MDF that I've used. Now, one of the reasons for using the slightly thicker MDF is ultimately I'm going to get at least 3 or 4 rounds of surfacing out of this particular spoilboard. So basically that means it should last me quite a long time. The other thing I should have pointed out as well before I stuck all this down is obviously make sure your bed is clean before you do so. Get rid of any debris, get rid of any oil marks, anything like that. Make sure it's good, clean to stick down. It just ensures everything's going to be much more solid when you put it all in place. Now, I should have mentioned this at the start of the video. All of the files that I'm using today I will give away for free down in the description area below. They will be in Carveco Maker. Obviously, if you're not familiar and you want to try that software out, I'll also put a link for a 90-day trial. And if you really want to get up and running as quick as possible with Carveco Maker, definitely check out our Jump Starter course over at Carveco Academy. You will literally be up and running in a short amount of time and have the confidence to do everything that you need. So definitely go and check that out as well. So I'm going to begin by surfacing the spoilboard and taking about 0.5 millimeter off the top of this to see how we're doing. Hopefully that should be enough, but in bad cases, you may find it is out by more than that. Now, when it comes to doing the surfacing and generating the file for it, this is easier than most people think. It is quite a simple process. Software such as GSender or OpenBuild Controller will generate you a file fairly quickly by just telling it how big your spoilboard is. Alternatively, jump into your favourite software such as Carveco, draw a rectangle out the same size as your spoilboard, maybe just a little bit bigger to ensure it cuts all the way to the edge, and then ultimately do that as a area clearance or a pocket cut and just set the depth to whatever you want to cut down. So as I say, the process is quite simple to generate that type of file. Now, the next tip I'm going to give you is about making sure we can see where it's actually being machined. Now, what I would recommend is taking a pencil and literally scribbling all over your spoilboard. Now, the reason for this is when we start machining things off, if it leaves a bit of pencil in one of the areas, we ultimately know it's not machined that area. So we need to run it again, go down a little bit lower and start it all again. And ultimately what you're looking to do is remove every pencil mark, and that way we know the spoilboard is then parallel with every axis and all of the spoilboard has been cut. So that's what I'm about to do now, just scribble all over this with a pencil. Now, when it comes to selecting a surfacing bit, you do have different choices. Probably one of the simplest methods is just to use a bog standard end mill that you may already have within your setup. Now, the downside to this is ultimately it is a smaller head, so therefore it's going to take a lot longer to surface your spoilboard. That is why we often move on to bits designed for surfacing. Now, this is a fairly cheap type of surfacing bit that you can get off places like Amazon. It does the job, it's really not bad at all, but ultimately they will fade quicker over time. So I often prefer to use these type of bits, which basically have replaceable carbide bits that can be rotated round or ultimately changed over for new ones. So today I'm going to be using this 1 1/4 inch bit right here in order to do the surfacing. So we're going to get the file prepped for that and ultimately load it onto the machine to start surfacing. Now, any eagle-eye viewer will notice this is not the bit I just said that I was actually going to use. I clearly made a miscalculation somewhere. I thought this bit would just about reach to the edge, but it actually doesn't. It's falling a little bit short. So reluctantly, I am about to use this 2 1/2 inch surfacing bit for the first time. I have no issue owning up to my mistakes. I say it was a miscalculation somewhere, but I've never used this bit before, and it honestly scares the life out of me. But ultimately, the next stage we need to do now is set this to the origin point of the job, the corner, set the Z height so it's just touching the surface of the material, and then we can run the spoilboard process. So everything is now set up. For anyone that's never used a Masso or this type of setup before, it's actually quite simple. You just head into the load file section, select the file off your USB stick, click load. You then go over to the jogging and program area, jog to your Z start position, make sure you zero it in the correct spot, which I have done. Obviously the Z is raised up slightly at the moment. Then you go over to the program area, and you can simply just start the job from here. So as I say, whilst it looks quite complicated on the surface, it is actually a fairly easy system to use. So everything is set up, all the zeros are in place. It is now time to start the job. Genuinely wish me luck, because that bit is scaring me as it stands. Now I've stopped this early on because what we can actually see is that it's already missing some parts. For example, this dark area here is where it has cut. This lighter area is where it's missing it. It's slightly grazed it, but we can still see the pencil marks. So ultimately it's not taken much off that surface. So what I'm going to do is bring it back to the start, lower it down another 0.5 millimeter and run it again. So ultimately try and get rid of all of the pencil marks. So we've now run a complete pass for the surfacing job, and what we can see is all of the pencil marks have now disappeared, which basically means we have taken a full top layer off the spoil board, and ultimately this should all now be parallel with the X and the Y axis. But ultimately that is the surfacing of the spoil board done. Now you could leave it at that, but we're going to take a look at tramming next. So I'm just wedging in an extra clip that I forgot to originally record, and I'm having to do it on my phone, so I do apologise for the audio difference. Now, in my videos, you will see me surface the spoil board first to get it parallel with the X and Y, and then tram the spindle in second in order to get that perpendicular. I find this the fastest and easier way. However, you can do it the other way around. Tram the spindle in first and do the surface in second. Mark Lindsay has a brilliant video on how to do this, and I'll put a link up in the corner. Bring it shortest way. Basically, use a flat piece of glass, put that on your bed. Use the Z-axis to measure the offsetting distance between each corner so you can see how uneven it is. You then shim up each corner to make that glass level, and then tram off the top of that. So as I say, if you want to do it that method and do the tramming first, check out Mark Lindsay's video. Otherwise, we'll carry on from where the video was going. Now, a big giveaway that your machine needs tramming is if you see lots of lines going across the MDF. One thing I will clarify is MDF is quite fibrous anyway, so you will typically see lines once it has finished doing its job. For example, you may just notice where around the edges where it's swept in different directions. But the giveaway is when you run your hand over it. If you can feel lumps and ridges, then there's a good chance your machine needs to be trammed in. If you don't feel anything, then ultimately that might mean that it's in a really good position to start with. But if you need to tram your machine, I'm going to quickly show you how to do it using some very simple jigs. So this is a very simple tramming jig that I have made. I've put the 3D file on Thingiverse. You can print one out yourself. You can buy tramming jigs. You can even do them with indicator dials as well. This is just a very cheap way of achieving it. Now ultimately the way that this works is this end here fits into the collet, and it ultimately magnifies any discrepancy going on within the spindle. Now ultimately the tramming is about keeping it perpendicular to the bed. So if it is leaning one way or another, it's going to give us a better indication of how much it is out because of, say, the magnification of the arm itself. Now don't worry, if you don't have a 3D printer or you don't want to buy a jig, you can always just do something like tape or zip tie two Allen keys together, and it will give you the exact same principle. This can then be spun around within the collet to do exactly the same job as the tramming jig to indicate which way the spindle is leaning. So I've just fitted the jig to the collet and you can start to see how it works. Now ideally you want to do this around the center of your work area because this is typically where it's going to be the worst spot. So bring it roughly to the center and start to lower it down slightly until this is about to touch the spoil board itself. And ultimately, then just swing it around and see where it starts to touch. Obviously, I've left a bit of clearance just for demonstration at this moment. But if let's say it is touching on the left-hand side, that means your spindle is leaning to the left. And ultimately, we would need to level it up that way. If it is touching on the front, for example, the spindle is leaning forward. Now, what you may find is sometimes it may touch, let's say, in a diagonal position. So you've got to correct it on both axes in order to fix that particular low spot. So ultimately, that is how it works. Just go around, let it scrape the bed wherever it is touching. That will indicate which way you need to correct the spindle. Now, do be careful when you are correcting it. You only want to do this incrementally, test it again, and then do another attempt, and ultimately just keep adjusting it with fine increments until it is an even touch all the way around. So I've lowered this down very gently to the point it starts to touch. And what we can actually see is from the left-hand side swinging round to the back to the right-hand side, it is not touching at all. But if we start to bring it round further, I don't know if the microphone will pick this up. You just start to hear it scrape from around this 90-degree position here. If we continue to bring it round, it scrapes heavier at the front. And again starts to fade back off round to this side, to the point it's not touching from about there. Now what that ultimately tells us, if that's the heaviest point it's touching right here, the spindle is leaning forward. Now naturally this is a very big spindle, that can sometimes happen, but it means we need to effectively pack the bottom of the Z-axis out to tilt this backwards in order to try and counteract that. Now depending on the CNC machine you have, there are different ways of doing it. With something like this, one of the easiest ways to do it is just slacken off the bottom bolts, maybe slacken the others off slightly as well, and then just put some shims of tin foil in the back of it in order to try and level that up. And that is exactly what I'm going to do now. So I'll double up the thickness of the amount of paper behind it, but what we can actually hear now is the front is clear, but as we swing it round to the back, it is just scratching on the back. So I've gone a fraction too far, so I now just need to either tighten the bolts a little bit more or take a little bit of the paper out to swing it back the other way. Sadly, this can be one of the pains of tramming your machine in, is it's fine work to get it back and forth. So hopefully what we can now hear is this is touching fairly evenly all the way around. It's scratching on the front, scratching on the left, scratching on the back, and scratching on the right. So basically that should mean that it's pretty perpendicular now with the bed on all axes, and that is the tramming done. Now when I've done spoil boards in the past, I would typically leave it at this point. We have fitted a spoil board, we have surfaced it, and we have also trammed in the spindle. So in theory, we are good to go. But what I found was the last time I did a larger scale spoil board, there was a few things I was missing that would have been very useful if I'd incorporated them. And I want to make sure I do on this one. So there are two things I'm going to be adding. One is something known as dog holes. If you're not familiar with these, it's basically a series of holes either in an L shape along the front and the side, or even in the middle of the bed itself. And what you can do with these holes is cut them like 3/4 of the way deep into your material, and then use little cuts of pipe like this, maybe 1 inch or 2 long, and it just gives you fixing positions in the bed itself to be able to push your material into and ultimately keep it in position. Now, usually the most important ones, as I say, is an L shape across the front, so you can always have a consistent starting corner for your material. But as I say, people do put them in the middle of the bed as well to give them more flexibility. Now, the second thing I'm going to be adding are these little threaded inserts. Now, one thing I noticed previously is having wider spans of T-track can get a little bit awkward when trying to clamp things in position. Either the clamps don't quite reach or are not in the position you want them to be to hold the material as best it can. So down the center of each strip here, I'm going to be putting a series of threaded inserts just to give me more clamping options. And also I'm going to be putting them in between the dog holes on the front and the left-hand side. One thing people often overlook is having something starting in your bottom left-hand corner can be difficult to actually clamp down in that corner. Now I'll show you my design on screen so you can understand what I'm trying to achieve, but essentially it's going to give me a solid fixing position in the bottom left-hand corner to always start my jobs, as well as lots of different clamping options where I can just move them about for the best availability depending on what it is I am trying to machine. So we'll crack on with that now and get all that machined. So let's take a closer look in a little bit more detail. Now for the threaded insert, I'm going to be machining holes at 8.7 millimeters wide, and these are going to go through the spoil board and the bed all the way out the other side, so these can be mounted from underneath. Now I do need to be very careful because ultimately I have the power unit and the VFD under here, so I need to be cautious around this area not to go into those or damage the bit on the mounting plates underneath. For the dog holes, what I'm going to be doing is machining those at 20 millimeters wide. That is the diameter of the tubing itself. I may add a little bit extra on just for tolerance so they do slide in nice and easy, but equally you don't want them to be too loose that they're wobbling about. And for these, I'm going to machine them about 18 millimeters deep, so it goes through the spoil board and just into the bed, but it doesn't go all the way through the bed because they basically need a resting position to sit within. Now for the threaded inserts, because we are going all the way through, in theory I should use an upcut bit to avoid blowing out the bottom, but ultimately my primary focus here is keeping the top surface as clean as possible. That's why I'm using a downtown bit. So there is a bit of a risk there, but as I say, I'd rather keep the top looking clean, and if the bottom blows out, then so be it. I could use a compression bit, but equally it's just easier to do it all with this, and I think it will be okay, especially considering it is MDF. So let's crack on and get those all machined. So that is all of the holes now cut. I did add an additional allowance onto the dog holes after I'd done the initial pass, because basically these went in, but they were a little bit too tight. Now they go in easy enough, but with a push down, they fit in nice and firm, no wobbling, and that is what you want. A tight hole, but not too tight that you can't pull them back out. Now what I need to do is go around from underneath and put in all of the threaded inserts. It did breach the bottom. Some of them have blown out a little bit, but ultimately, as I say, I was happy to accept that to get a clean finish on the surface. So this is going to take a while. I better get started. So all of the inserts are now in place. One final step I'm going to do is just put a bit of an alignment grid with a V-bit on the bed. So I've got some references on the X and Y axis if I need to put material elsewhere, just to make sure that it is parallel to the axis. I've installed a 90-degree V-bit. I've already added the grid to my file. About to load it in, and we'll let that run. So that is my spoil board done. I've even engraved the little Onefinity logo right here on the spoil board itself. Obviously, every time I resurface this, I'll probably need to put the grids in again, but I am happy with that because this spoil board should last me quite a while now. One thing I will point out is the piece that I've got right in the corner here. If you are putting square material into there, you don't need that one on the corner. Take that out, and that will allow your piece to slot right in. If you leave it in, it's never going to sit perfectly in that corner. So just something to bear in mind. You could ultimately modify this and put them slightly offset so you do have that perfect positioning corner. But the joys of this is it can just come out, and that way I can get my piece right in there. So do hope you found this useful. I will share all the files with this video. Thank you all very much for watching. Final thanks as always goes to my patrons. I'll see you all on the next episode.